My name is Vince Baker, and I'm an applications architect for William Hill. And what I'm going to tell you today is a high-level overview of our API infrastructure and explain the hurdles we face and the key events we support. Right, about me, first of all. Hang on. We'll get there. Here we go. Didn't realize how bad that picture looks when it's so big. Anyway, I grew up in the, first married to my beautiful wife with 2 young kids. I grew up in the 70s and 80s playing around with computers. My first exposure was a Sharp MZ80K, really old school. Then I got my own VIC-20 and Commodore VIC-64, etc. So, you know, fairly early on with computers at home when I was a kid. After leaving school, I spent 10 years as a refrigeration engineer, working in big Sainsbury's stores, putting in pipe work, things like that. And then the dot-com boom came, which gave me a chance to follow my dream career in IT, where I started contract for British Telecom as a Windows sysadmin just a few miles away from my home. This led on to many contract changes and learning new skills in each role, Unix, Oracle, networking, etc. Then 10 years later, I was offered a permanent role at Mansion Gaming in Gibraltar. So this made me move from the UK over to the south of Spain. Basically, this is the southern tip of Spain. Here, I caught up on VMware, Puppet, etc., which other companies I worked for in the past were lacking. They were very old school. BT was fairly old school. Then, 3 years ago, I jumped ship and joined William Hill as a systems integrator, mainly looking after and scaling the CA gateway infrastructure for the business needs. I then recently became an applications architect, which is the job I'd really been doing for a while anyway, but now I'm getting more recognized for it. I'm continuously learning how to improve our gateway implementation, and that's why I'm here today, to learn and share. Okay, William Hill. Most British people, I should say, will know William Hill as an established bookmaker or sports betting company. We like to be known as the English gentleman of bookmaking and gambling. It was founded in the north of England by William Hill in 1934 as a postal and telephone betting service. So with the telephone side, he was using technology in the business really early on. Now we have 16,000 employees. Retail offices, or betting shops, are common in the UK high streets. The online business is run from the UK, Gibraltar, Italy, Spain, Bulgaria, Israel, Poland, Manila, Australia, and right here in Vegas. So that should say actually 10. I think it says 8 different countries. I added a couple more a couple of days ago. But my UX guy couldn't update the slides by then. Production support is run out of the UK, and development from Gibraltar, Poland, and London. Right, our team. This is our team, just like the API team within William Hill. It's the William Hill API team, also known as the WAPI team. We want to change that name because it just sounds a bit silly, to be honest. We are based in Gibraltar, which is a British territory on the little tail at the bottom of Spain, almost touching Africa, if you don't know it. In our team, we have the product owner, product manager, policy developers, comprehensive QA team, business architect, system engineers, solutions architect, business affiliate and support, and me, the applications architect. We also have countless other resources that within William Hill, such as networks, InfoSec, server ops, capacity management, monitoring. I was going to say welcome Andy, but I don't see Andy here. He said he was going to be here. He's here from William Hill. Brand, UX, cloud, just to name a few. Okay, our gateways. We have quite a lot of gateways to manage. It's mainly my fault, because I've just tried to get as many as I can, being they're free to my part of the business. There are 6 non-prod clusters. These include development, pre-prod, staging, and performance test. Our production environment is split into 2 geographic locations, UK and Gibraltar, but I'll detail the reasons why and all about that in a few minutes. Disaster recovery is made up of 2 clusters in a data center in Canada. We're currently looking at moving that as well. Our API portals are solely used by our team for key management, and rates and quotas, etc. We no longer give portal access to partners. It's not a necessity for us. We currently use ESM for release and migration. However, we're working on some automation with GMU. I think the 9.3 is going to help us a lot. Something I want to do as soon as I get back to the office is incorporate GMU with Git for version control and get a really decent release process. At the moment, it takes far too long, the way we're doing it, and too many people. Right, production traffic flow. Okay, as mentioned, our production environment is spread between the UK and Gibraltar. As much of our traffic, I should say, is UK-based, we try to handle as many of the requests from there as possible. But due to licensing and gambling laws, bets and betting-related requests must be processed in Gibraltar. So if the request is a bet, for example, the UK gateways receive the request, and then they pass the relevant part, which I can get into in a minute, relevant part of the request downstream to the Gibraltar gateways for processing there. And then the bet can be struck there legally and for tax reasons as much as anything. Gibraltar is where we effectively take our money. So we have a 2+1 failover in Gib. So in Gibraltar we have three clusters. We can take any one out and still have redundancy. So we can do upgrades easily and still have redundancy. If UK fails, we can always switch our UK DNS to the Gibraltar VIP, as all our policies go in basically all clusters. So, because we have many clusters in one portal, we currently use custom sync scripts for key and metadata propagation. This isn't without its problems, and we're now working on a v4 multi-cluster aware portal. We don't like the scripts too much now. It's not scalable. The scripts weren't scalable, so we're now working on that. Okay. Policy framework. My predecessor, and I still work with him, but he's back as a contractor now, worked on this policy framework, and he did a great job on it. We've created a set of REST standards. Sorry, his name is Christian Holm. He wanted a bit of a name check, so I've done that. We've create a set of REST standards throughout William Hill and adopted Swagger as the specification to be used throughout the whole set. We built a framework, which we call the V2 framework, on the gateways with the following features. Environment abstraction. What do I mean by this? The framework contains a full mapping of our environments, and all policies and cluster-wide properties can be deployed to all environments. The gateways then use the correct values depending on their position within the mapping. So everything goes everywhere, and each gateway knows where it is within that environment. Automatic process of CORS and REST standards on the gateway. The framework, so when we build a policy, we don't have to do this stuff. It's all there always for all policies. The framework automatically handles administration calls like options, head, route summary, and documentation. Fatal error handling. This is an enhanced error handling method which can give back finer detail and also handle multiple errors instead of only giving back the last one, for instance. Default payload definitions. Yeah. This allows API consumers, sorry. You can see I'm reading this, can't you? This allows API consumers to accept a default set of fields, or they can specify just the required fields they want. This reduces bandwidth. Developer-focused JSON payloads across the full API suite. This is just our way to make developers' jobs easier. Just make sure that developers are happy, more than anything. Automatic documentation and SDK generation using Swagger. Here we automatically inject a /docs into each API. Currently, the system supports Objective-C, JavaScript, Java, and HTML documentation. So basically, documentation is always up to date. If you go to the API/docs, you'll get it. Dynamic logging with multiple logging levels. This one's very good for us, especially when we're talking about performance. We can specify individual logging levels to a cluster, node, API, API key, or even a combination of these. We can also control this via our internal admin API, which will manipulate the logging levels on the fly. So for safety reasons, verbose logging can never be left on, as the timeout value is held in cache and will return to the default cluster-wide property when the cache expires. This means that we can keep all our logs to a really small amount of information until we have a little bit of a problem and we can turn them up for just one API or one node. It makes it ideal. We can even take one node out of the load balancer and then hit it direct and see the logs quite verbose. Okay, we also have a dynamic routing API system. This is an optional pre-processing on the initial environment. So we had the UK clusters and then the JIB clusters. If the call comes into the UK, then we can do pre-processing before it gets to JIB. We can deploy all APIs to all environments as they are aware of their position and can route themselves to other environments for processing if needed. This also can be adjusted through our internal admin API. Node status system. This is mainly for our F5s, for our load balancing, and for my sanity when it comes to doing releases and things. This is a way for our load balancers to decide whether a node should be in the production pool or not. This is handy for masking nodes or clusters during upgrades and releases. This also is adjustable via our internal API. Basically, it's a probe, it's a monitor on the F5, calls an API and says, are you in or out? And if it's in, it puts it in the pool. If it's out, it's out. And we can control these. So I don't have to go back to networks and say, right, we need to take these nodes out of the pool and raise changes and things. It's all fairly automated. Automatic back-end calling. Right. If a back-end fully supports our REST standards, then we can fully generate an API using just a Swagger definition. So just using the Swagger definition, we can fully generate an API. Dashboard interface. This is the interface that I was talking about, where we have nice. I haven't actually put it up on here. I could have done, so it looks pretty. This is a GUI we created to control the admin API, which I've mentioned a few times. Apart from controlling and viewing the node status, logging and routing, it can also show full API documentation in real time from each API. So that's always up to date. Handy for our developers and testers. So I'm just going to grab a drink of water because my mouth has gone dry. Okay, the dev backlog. Basically, this is our to-do list. Stuff we're planning to do, but never quite got the time to do it. We're introducing some back-end service failure detection and rerouting. This is similar to the new circuit breaker feature, which I believe is being demoed at one of the booths here. This will automatically reroute traffic to another environment for X minutes, allowing support teams some time to repair the original, along with generating alarms. We haven't done this because we actually planned this about the same time as CA did theirs, but it's sort of in its proof of concept at the moment. Pseudo APIs. We'll be able to create bespoke APIs that sit on top of our core APIs. With this, an API key can be authorized to access specific endpoints of different core APIs. Basically, it's a customizable wrapper. So we don't have to give people access to everything on every API they want. We can just say, okay, you want that part of that one, that part of that one, and that part of that one. And they can have it with one API key. Response payload specification. This will go hand in hand with the pseudo APIs and is a simple version of GraphQL and will allow the developer to specify the fields and the structure of the response from the gateway. So they can get it back as they want it. They can specify what they want. Adaptation for micro gateways. We currently have the infrastructure in place. Our platform as a service uses Docker, Marathon, Mesos, and we're using Consul as a service registry. Right, key events. This is all about our spikiness of traffic. We provide some constant feed data to companies, which keeps a steady but quite high background noise of traffic. Saturday afternoons, Our traffic tends to have steady increases during the day, but marketing and sports events cause sharp peaks. Saturday afternoons are our main weekly focus. This is when the most horse racing and soccer games are held. Boxing Day. The lazy day, I should say, after Christmas, with plenty of people sitting in front of the TV, watching and participating in sports by betting on them. Cheltenham Festival. This is similar to the US Breeders' Cup, but held over 4 days. So it's a fairly big one for us, that one. But then, this is the biggie for us, Grand National. This is a single 4.5 mile race with large fences held at the end of the big racing day at Aintree Racecourse in Liverpool, UK. It's held at the beginning of April each year. Grand National Day is very well known by everybody in the UK, and I believe is similar to the Kentucky Derby in the States. Anyway, let's see some stats. Okay, daily peaks. My UX guy got this, and he didn't have exactly all the right figures, so you might see a little bit different to what I'm telling you. But yeah, daily peak is around 300 requests per second. Saturday afternoons are full of events, so we get a lot more traffic, around 1,200. Boxing Day, just an elevated Saturday afternoon, around 2,200. This is requests per second, which is a fair amount, excuse me. Now for the Grand National. This completely blows everything out of the water. We spend several months leading up to this event, analysing all scenarios and performing daily load tests, as it's the most visible event in the media. If we go down on this day, the UK knows about it, basically, or half the UK. The actual peak figure on this is about 11,500 requests per second. The exact figures there are showing a little bit off. But yeah, I will mention that these requests aren't calling a small policy. There's a lot of work being performed by the gateways for each request, including our V2 framework that has to go through all this and decide whether it's doing this logging, whether it's going to be doing the routing and everything. They're not small policies. Most of them are 300 or 400 lines of policy, big ones. Right, now if we go back and look at these daily peaks again, these daily figures are about 6 months old and have increased, almost doubled our regular traffic. So I'm wondering what the figures the business is going to predict for this year's Grand National, this next April. It looks like I might have to make the gateways a bit faster, because I think if we've doubled these, then I think these are going to be a lot higher. Hopefully 9.2 will help. Right, okay, you can see that probably just about. I'm going to explain it a bit anyway. Basically, this graph shows the gateway incoming traffic rates around the time of the Grand National race. This is a Splunk output. We logged to Splunk. And the logging was a little latent. Splunk wasn't quite performing as well as we wanted it to, so I had to show this on a 5-second average. I couldn't show it on a 1 second, as it was too spiky. It was like low, big, small, terrible. The per second peaks on this, 1 5-second peak, were probably much higher than the 11,000 it shows here. But there was no way to measure it. We just couldn't measure it at the time. This year, we scaled up the gateways dramatically and moved from 8.102 to version 9. This is much more robust than 8.102. We have since moved to 9.2, which, as usual, hasn't been without its upgrade pitfalls, but I'm hoping the stability is still there. Our load testing shows it's okay, but it's very hard to simulate a whole nation pressing their get account balance buttons at the same time at the end of each race. Right, okay, this one. This is an example of the concurrent TCP connections to each node. About 1,700. This is from a Wiley output. Sorry, APM, I should say. About 1,700 each node. This equates to 36,000 concurrent connections to our gateway at the time. This graph is just basically a CPU load of each gateway in one of our clusters, but it shows that they stay consistently in line with the others. This is just one cluster, but it shows that they all show around the same figures. So we've got up there less than about 50% CPU. and nothing went wild at all. Okay, so a summary of sort of how we did this. Horizontal scaling. We increased the node count in Gibraltar from 12 to 24. This is where the money is generated, and this is where the peaks occur. We now have had a few more customers that are coming into our SCC, our UK data center, and they are hitting us with some fairly high traffic 24/7. So I'm going to have to start looking at increasing the node count in UK as well, I think, for this year. The V2 framework helped reduce the logging verbosity. It helped by dropping logging to around 15 entries per request instead of 40. I think logging was a big thing, and we've actually managed to be able to get that down even further now. All the request IDs used to be different on 8.102. Now they're the same, and so we had to log like a request chain. We don't have to do that anymore. So that hopefully is taken a little bit more load off the Splunk back end and actually transmitting it. The IO HTTP core concurrency and max was set up so that we had enough initial TCP connections available. Now, we had the problem. This is because if you let the gateways build connections on the fly, so the difference between IO HTTP core and IO HTTP max, it takes a lot of processor. It seems to. In performance tests we found. So we need to bring those the actual core up as much as we can towards the max. Also, now this figure is higher. The system properties TCP connection limit per host comes into effect, which in turn limits the outgoing connections to a latent back-end service. This allows the gateway to still connect to other back-end services and helps prevent the max concurrency figure becoming reached. Basically, if a host becomes latent, then this setting that we set in the system.properties will stop the connections to that one host, but still let the other connections come without filling up our max and blocking the gateway completely. We played around with the load balancers. CA said, try using least connections. We did that, but found that the service processor, if the service processor restarts a gateway during high load, then that gateway gets flooded with requests upon startup at a high rate, which, while its load average is still high, and it couldn't get back on its feet. We had this 2 years ago on the Grand National, where some nodes restarted themselves. The service processor saw that they weren't available, and it tried to restart them, and they couldn't restart. As soon as they came up and port 8443 came up, that was it. They were flooded with requests, and it was just, your load average was up to hundreds, so it didn't work. So this wasn't going to work at all. So we went back to round robin. So at least then, not one single node would suddenly get all that traffic coming in because it had got no connections to it originally. We also had our lucky charm with us on that day, on the last Grand National. We felt we needed CA support to be immediately on hand, because in this situation with the Grand National, seconds count. So we had Chris Clark, who was our top support guy at the time, based in the UK. He's since got promotion or moved. And fortunately, he wasn't needed, but he just spectated. However, he was able to feed back the experience to the rest of his team. Now, I try and organize meetings with the support guys every few months, and try and sit down with them and say, okay, these are what our systems are like at the moment. It does help with support. If I speak to any of the support guys, I don't have to go through the rigmarole of telling them how many gateways we've got, about all our custom metadata, you name it. I try and get to Ditton Park in the UK every few months. But that's about it, really. In summary, we have very, very spiky traffic. Maybe we want to look at using micro gateways a bit more and being able to spool up and spool down. That might help. But on these days, we expect traffic to be like high and then massive. So I've still got almost 5 minutes left.